Okay, so today we're going to do a little troubleshooting on our gas simulator to kind of demonstrate what we would do in the event of a no heat situation, a no heat service call. Okay, so here we are again on your on the Simutech Simu-Gas simulator. And this time, if you notice, instead of just the run normal button, we now have the run fault button now also activated. Once you are on the simulator and ready to do your simulator faults, you will log on to the simulator as you did before, and what you will do is you will come over to File, and then you will see User Logon. Once click on User Logon, find your name, click on it, and hit OK. It's going to ask you for a password. There is no password. Just hit OK, and it will bring you over to your run fault. So today we're going to do a demonstration on how to use the simulator to repair a no heat call. So what we're going to do is we're going to click on Run Fault. The first thing it does, it gives you a service order. Okay, in this case, hey, it's Test Student. Hi, how are you? It's me. Wonderful. You got a standard efficiency type furnace. So in this case, it's a standing pilot furnace, and the customer is complaining that the burners and blower remain off even if the fan switch is in the on position. So that's what the customer is complaining. Okay, so that gives you a baseline of what to maybe look for in a service call. What is the customer complaining of? Well, in this case, this customer is saying that, hey, nothing's happening. My burner, my blowers are off. Even if I hit the switch to the on position, I try to mess around with the thermostat, nothing's happening. Okay, so let's see what's going on. So it brings us over to our screen. All right, well, it's a standing pilot furnace. Knowing the sequence of operation, the first thing that we should possibly do is, hey, well, maybe we should see whether or not the pilot lights, right? Because after all, we need to have a pilot in order to ignite the main burners. Anyway, right? So why don't we try that? So we come over to here, let's turn our gas valve to pilot. Let's hit our little match. Okay, well, that's pretty good, right? The flame, our pilot came on, so that's good. So it tells us that at least we have gas, right? That's the first thing. So we got to wait. We got to look around, right? We could look at our wiring diagram. Okay, so right, we got our circuit breaker. Okay, we got our blower relay. We got a fan limit switch. We got our burner motor. Got our burner motor capacitor. Okay, so that's one line of our diagram. Okay, we got a normally open blower relay, which is wired to our high speed. Well, we could take that into consideration, but is it really that important right now? Probably not. But hey, it's there, right? That's our line number 2 of our wiring diagram. Line 3, okay, I got a high limit switch, which is wired in series with my transformer. All right, so there's line 4, my secondary, my 24 volts, right, which now powers up my thermostat, which then in turn powers up my gas valve. I got my thermocouple, and I got my fan switch, my burner relay, my coil for my burner relay. Okay, well, let's see. Well, let's go back to the other screen, and let's turn the gas valve on. Let's see what happens. Okay. We know that the pilot light stays lit because we know that by looking at our diagram, the thermocouple is its own circuit. The pilot's staying lit. So that's telling me that this thermocouple is getting hot enough, it's generating enough electrical energy, enough electrical voltage, millivolts, to energize my coil inside my gas valve to keep the pilot coil lit and open so that I can have a pilot flame. Okay, I can rule this out. This is working. All right, so what could it possibly be? Well, let's go back. let's turn on our circuit breaker. Let's see. Our circuit breaker is on right now. My circuit breaker is closed. Okay, so I could take my voltmeter. Let's go across. Let's go across my circuit. Okay, 115 volts. All right, let's see. Let's go across our, what's another one that we can use? Let's see, we got, what about our burner relay number 1? Let's see, can we go across that? Yep, yes we can. Okay, let's see. 0 volts. What do we know with a voltmeter? 0 volts across a closed switch means it's closed. All right, good. Let's move on to the next one. Let's go to our fan limit switch. What about our fan limit switch? Okay, 115 volts. Okay, source voltage across this switch indicates that the fan limit switch is in the open position, which means that the blower is most likely not on. So let's go over to our blower. Let's see. Where's my blower? Right there. Let's go there. 0 volts. Okay? I'm not getting anything. Why? Because that switch is open. I do not have a complete path for the electricity to flow. Okay. So that's a telltale sign. My fan limit switch didn't close. Why? Why didn't it close? Well, that's because my main burners aren't on. Well, what do we got to do to get the main burners to ignite? Well, let's go back to our electrical diagram. All right. Well, where's my main burner? Where's my burners? Right here. Here's my main valve. Here's my pilot coil, which is energizing my thermocouple. And my thermocouple is energizing my main coil, or pilot coil, sorry. And I got my main valve, which is right here. So what is happening here? Well, got my thermostat. 24 volts. Powers up my R through my thermostat. Is my thermostat closed? Well, let's see. Let's go to R and W. Okay, thermostat is closed, right? Reading 0 across a closed switch. So why is it not energizing? What's going on? Am I getting voltage to my coil on my gas valve? Let's see, gas valve coil. Here we go. Let's go there. Nothing. I'm not even getting power to my main valve. So what is going on here? I'm not getting 24 volts. My switch is closed, but I don't get 24 volts here. So where should I go? What should I do? Where is my voltage supposed to be coming from? Again, this is why we need to know that sequence of operation. Okay? That power that's going to energize my main valve is coming from my transformer. It's right here. Am I getting 24 volts out of my transformer? Let's see. Where's my transformer? Transformer secondary. Let's go over here. Oh. That's no good. I'm not getting any voltage out of my 24 volt side. Do I have 115 volts going into my primary? Is my high limit switch maybe open? Well, let's see. Let's go to my primary side. Let's see. Do I have 115 volts maybe to my primary? I do. Okay, so I'm getting power from my L1 and my neutral, which is coming down here, which is telling me that my high limit switch is indeed closed because I am powering up my transformer. Because remember, in a transformer, you have both a load and a source. My load, in this case, is my primary side, my 115. So I'm using the electrical energy from the transformer to produce 24 volts so that I can power up the rest of my circuit. I don't have that right now. So what could be wrong? What should we be doing next? Well, we have already indicated that I got nothing coming out of my transformer. Okay? Is there something wrong with the transformer? Yeah, there is. Because remember, in a transformer, you have a primary winding and a secondary winding. They don't touch in any sort of way. Okay, it's all produced through a magnetic field, through that iron core that is around the center of the transformer. So I need to take this a step further. I have no voltage coming out of the transformer. I need to figure out why that is. We know that it has two windings. We have a primary winding. We have a secondary winding. What can I do to figure out if there's something wrong with my coil? The only way I can ever confirm whether or not I have a good coil or a bad coil is by ohming it out. Okay, I have to ohm out my loads in order to confirm whether or not a load is good or bad. Okay, if a load is good, I'm going to get a resistance reading because it's a load. Okay, I'm doing something with the electrical energy. If I get a 0, it means it's shorted. Okay? If I read OL, open load, OL, it means that it's open, which means somewhere in the winding itself, a wire has broken apart. They're no longer a point from point A to point B. I'm not completing a path. So, let's see. Anytime we do a resistance reading on any sort of load, we need to make sure that we shut the power off. If we do not do that, we will damage our meters in real life. Okay, so what we're going to do is we're going to come over here. We're going to do an ohm reading. Okay, let's ohm across our primary side. Okay, I'm getting 100 ohms of resistance. That's telling me that this wire is still good. It's still intact. Okay? If I go across my secondary winding on my transformer, I'm reading OL. I'm reading between this point and this point. That's telling me that this coil right here, somewhere in there, that winding has now broken apart. I do not have a complete path or continuity for that electricity to flow. Remember, source, path, switch, load. Okay, 24 volts would be our source, which is going to be controlling and supplying the power to all of this stuff down here. If I don't have a source, nothing's going to happen. Okay, so I need to repair or replace my transformer. So how the hell do I do that? Well, let's go over here. I'm going to come up here to my little hammer and nails and my little wrench. Okay? And I'm going to find what's going on here. Okay? Pilot cannot light. Well, that's not true because it lights. Okay? Pilot goes out when gas valve is set to the on position. That didn't happen. Pilot goes out during a heating cycle. No. Okay? Pilot lit, but burners won't ignite. Your blower is inoperative. That sounds about right. Right? I got a pilot that lights, but my main burner can't come on, and my blower isn't going to come on. Okay, so let's come over here. Let's click on that. Let's hit OK. Okay, my possible causes. Do I have a high limit switch? That was no good. Well, we figured that out before because I saw that I had 115 volts of electricity at my primary side of my winding of my transformer. So that tells me that that limit switch is still closed. So that couldn't have been the problem. We know I had no 24-volt control voltage at all. Okay? It gives me a couple other possible reasons why I would have no 24-volt control voltage. Well, is the high limit open? Again, back to what I said. I was getting 115 volts on my primary side of my transformer, which tells me that that limit switch is closed. Okay? Did I have a trip breaker? Nope, that couldn't have been it because I was still getting 115. Couldn't be the trip breaker. No power to the circuit breaker? Well, that still can't be it because, again, I had 115 volts. I had 115 volts powering up my transformer. So it could not have been that. Do I have an open or shorted control transformer? We figured that out. Why? Because I had OL on my secondary side of my transformer. So I'm going to click that. Okay, I'm going to repair it. Okay, tells me that I'm good. Look at that. My transformer has now went from OL to 5 ohms of resistance. I have repaired and replaced my transformer. Okay, so if I want to test this again, let's go over to my mechanical side. You'll see that the pilot is still lit. Okay, let's turn that off. Let's redo it. Okay, again, go to pilot. Let's light it. Okay, and if you notice, if I do it too quickly, it goes out. Okay, I have to wait that 1 minute in order for this to work properly. So again, we'll go there. Okay, I'm going to raise the runtime just for the sake of not having to wait an entire minute, but I do not recommend that you guys do this. I want you guys to watch this and learn how it happens. Okay, once that has been a minute, I'm now going to turn my power to my gas burner to the on position. Oh, I forgot to do one thing. See what happens? I have to take off my voltmeter or my ohm meter. Now I could turn it on. Okay, I don't know if you heard the little zap, but that's what happens if you don't do something correctly. Okay, now you notice my main burners have now come on. I can now take my temperature readings, and you will see that I am starting to raise in temperature, and that will give me time to watch and see what's going on with my circuit. Okay, and again, we notice that our blower hasn't come on just yet. That's because we're still warming up. Well, if I go over to my schematic over here and I click on my fan limit switch, you'll see that I'm reading 115 volts, because again, that's telling me that that switch is still open and it hasn't closed. So at about approximately 130 degrees or so, you will see that the fan limit switch will close and the blower will come on, and that's how I know that I have completed my fault and the furnace is working 100% the way it's supposed to be. Okay, this is where I want everybody to understand, is that you do need to understand sequence of operation in order to properly troubleshoot and fix a gas furnace. If we have a problem with that, you are going to have a problem in real life trying to fix a furnace. It's also important to know that, yes, you do need to understand how a wiring diagram works, but you also need to understand that sequence of operation. If you know those two on how it's supposed to work and when things are supposed to happen when, understanding a wiring diagram is much more easier to understand and what to do. Okay? Not understanding how a furnace works is really what makes things complicated for a mechanic. And there you go. Went to 0. So that's telling me that that switch is now closed, and if you notice, it did close because the animation is on, so you guys can see this. Come over, there's my blower. Okay, 130 degrees, my blower came on. I'm delivering heat to the space. If I satisfy my thermostat, raise my room temperature, look at that. My main burner has shut off. My blower is still on because now I have to allow my furnace to cool off and get rid of that residual heat that is sitting in there. Okay, so at about approximately 100, maybe 90 degrees, somewhere's in there, Okay, and I'm just going to lower it down really quick just so that you can see. You will see the fan limit switch is now opened. My blower has turned off. I'm again reading 115 volts across an open switch.